Hello viewers, in this class we are going to look at angular bisector of a triangle and its intersection point in center and its various properties. I am taking a triangle. Here AD is an angular bisector of a triangle. It bisects the angle A. Here I am taking, if it is phi, this angle is 180 minus phi. I am applying sine rule. First, in triangle ABD, take the side, length of side which is opposite to angle C as C, length of side which is opposite to B as B, this is A, or else we will take it as by their names itself. So, we say opposite to theta we have BD, BD by sin theta is equals to AB by its opposite angle is opposite sine angle becomes sin phi. From this sin theta by sin phi is equals to BD by AB. Now look at the triangle ADC. In triangle ADC also, if you look at, take angle which is opposite to side which is opposite to angle theta, that is CD. So consider in triangle ADC, side DC is opposite to sine, therefore DC by sin theta is equals to 180 minus phi, the side which is opposite to that is AC, AC by sin 180 minus phi. We all know sin 180 minus theta or sin 180 minus phi is same as sin phi, therefore sin theta by sin phi is equals to DC by AC. From equation number 1, equation number 2, I can say BD by AB is equals to DC by AC. From this I can say BD is to DC is equals to AB is to AC. This is very important property of a angular bisector. So here an angular bisector of a triangle. So for this triangular angular bisector AD divides the opposite side BC. Angular bisector of a triangle AD divides the opposite sides BC in the ratio of its adjacent sides. Now what are its adjacent sides? The adjacent sides are AB and AC. So if you want BD, in this, it divides BD in the ratio of C is to B. It divides BC in the ratio of C is to B. I would say C out of B plus C into side A. If you want DC, which is equals to B out of B plus C into that side A. Now here in this triangle I am taking two internal angular bisectors. Let the triangle be ABC. Here BD and CD are the angular bisector of triangle ABC. Let this be, let angle B is equals to 2x, angle C is equals to 2y. So it bisects the angle, therefore x, x. It bisects the angle, therefore y and y. If it is theta, here our aim is to find out this angle theta. First in triangle ABC, two x plus 2y plus angle A. is equals to 180. x plus y is equals to, divide everything by 2, it becomes 90 minus angle A by 2. This angle A, sometimes you also refer to it as angle BAC by 2. Remember it as an equation 1. It is very important in upcoming derivations. Remember that x plus y is equals to 90 minus angle A by 2 or else angle BAC by 2. Both of them are same here. Now consider triangle BDC. In BDC, x plus y plus theta is equals to 180. Theta is equals to 180 minus x plus y. If you substitute x plus y here, 180 minus 90 becomes 90 degrees. Minus of minus becomes plus, therefore plus angle A by 2. So remember this theta, the angle formed at the two internal bisectors of a triangle is 90 plus the third angle by 2. So here I am taking two internal bisectors. These are internal bisectors. Now I will take two external bisectors. Here I am taking two external bisectors. These are external bisectors, external angular bisectors. We have already considered the angle B as 2x, angle C becomes 2y. Remaining angle here is 180 minus 2x. If you divide 180 minus 2x by 2, this whole entire angle is 180 minus 2x, remaining angle outside. If you divide it by 2, it becomes 90 minus x. Therefore, this angle is 90 minus x. We know vertically opposite angles are equal. Therefore, this becomes 90 minus x. This becomes 90 minus y. This is angle A. We just need to find out angle BDC. Two external angular bisectors meet. Let this be theta again. So in this triangle, 90 minus x plus 90 minus y plus theta is equals to 180. 180 cancel, theta is equals to, you get x plus y. We know x plus y is equals to 90 minus angle A by 2. So angle formed when two external angular bisectors meet is 90 minus A by 2. We have seen when two internal bisectors meet, it is 90 plus A by 2. Now we will take one internal bisector and one external bisector. So here in this figure, you see one internal bisector and one external bisector. This one is an internal bisector, internal angular bisector. This is an external angular bisector. Let us take it as triangle ABC. This is D. Again I am considering it as theta. This angle becomes x because it is 2x. Here it is 2y. This is 90 minus y. Because if you look at the external, the entire external angle becomes 180 minus 2y. You just divide it by 2, it becomes 90 minus y. Now consider in triangle again BDC. X plus 2y plus 90 minus y plus theta is equals to 180. X plus y, you got it. X plus y is nothing but 90 minus A by 2 plus 90 plus theta is equals to 180. 180 gets cancelled. Theta here is equals to angle A by 2. So when one internal angular bisector and one external angular bisectors meet, the angle formed here is the opposite is nothing but third angle by 2. The angle formed by internal angular bisector, external angular bisector is third angle by 2. Let's look at all the three in a single figure. In this figure, ABC is the triangle. Two internal angular bisectors meet, it is an in center, I am taking it as I. This is I dash where two external angular bisectors meet. I double dash is one internal and one external angular bisector meet. This is internal angular bisector. This one is external angular bisector. We know BIC 90 plus angle A by 2. BI dash C 90 minus angle A by 2. BI double dash C is simply angle A by 2. So here these three are very important when it comes to angular bisector. Now we will look at some problems based on angular bisector. Let's look at the first problem based on this angular bisector. The external angular bisectors of angle B and angle C of triangle ABC meet at the point P. In the explanation I said it is D, but here it is given as angle P, point P. If BAC is nothing but angle A is 80, then BPC. Without figure we can say angle BPC is equals to two external angular bisectors, therefore 90 minus angle BAC by 2. So here angle BAC is 80 divided by 2. So 90 minus 40 is 50 degrees. Let's look at the next question. The external bisectors of angle B and angle C of triangle ABC, where AB and AC extended to E and F respectively meet at point P. If BAC is equals to 100, then the measure of BPC, it is same as the previous one. We know when two external angular bisectors meet, angle BPC is equals to 90 minus angle A by 2 or else angle BAC by 2. So here it is 90 minus 100 by 2 is 50, 90 minus 50 is equals to 40. So here this question is also based on external bisector. Look at the next question here. ABC is the triangle. The bisectors of the internal angle B and the external angle C intersect at D. In this triangle, one is internal angular bisector and the other one is an external angular bisector, and BDC is given is 50 degrees, then angle A. So you can consider this figure. You are already familiar with this. If this angle is given as 50, BDC, one is internal, one external, then what is A? We know angle BDC is equals to angle A by 2. Therefore, angle A is equals to 2 times of angle BDC, which is 2 times of 50, 100 degrees. Look at this one. If the triangle ABC, the bisectors of angle B and C intersect at O, the bisectors, which means if nothing is mentioned, you take the internal bisectors of B and C meet at O, which of the following statements is correct? Look at the statements here. Angle BOC is equals to 90. We know when two internal angular bisectors meet, the angle BOC is equals to 90 plus A by 2. We take it as 90 plus A by 2 is the answer, because these are two internal angular bisectors. Look at the next question now. Here in this triangle ABC, in center is O. In center, we know in center is a line which is intersection of angular bisectors, and angle BOC is equals to 110. then the measure of BAC. We know BOC, two internal angular bisectors, then we can say 90 plus angle A by 2. If it is 110 is equals to 90 plus angle A by 2. Angle A by 2 is 20, therefore angle A is equals to 40 degrees. Look at the next question. O is the incenter of triangle ABC and angle A is equals to 30, then BOC. Incenter means it is an intersection point of angular bisector. Therefore, we know direct formula BOC is equals to 90 plus A by 2. So, 90 plus 30 by 2 is 15. So, it is 105 degrees here. If the incenter of triangle ABC is equals to triangle ABC and A is equals to 60, then the value of BIC. Here BIC is clearly is the angle formed by two internal bisectors. We know it as 90 plus A by 2. So, A is 60 degrees, 90 plus 60 by 2, we take 90 plus 60 by 2. It is 90 plus 30, which is 120 degrees. Look at here. If I is the incenter of triangle ABC and BIC is 135 degrees, then BABC, triangle ABC is what kind of triangle he is asking you. In order to say the triangle ABC is which kind of triangle, you need to find out angle A here. Now, BIC is an angle formed by two internal bisectors. So, we know angle BIC is equals to 90 plus A by 2. So, 90 plus A by 2 or else A by 2 plus 90 is equals to 135. Angle A is equals to 2 times of 45. So, angle A is equals to 90 degrees. So, if angle A is equals to 90 degrees, we call A is a right angle triangle. Suppose if angle A is greater than 90, then we say triangle is a acute angle triangle. So, we can't say anything about equilateral and obtuse by using this property. Look at the next one. I is the incenter of a triangle ABC. If triangle ABC is equals to 65 and triangle ACB is equals to 55 degrees, angle ABC is equals to 65 degrees and angle ACB is equals to 55, the value of BIC. So, here angle ABC is nothing but angle B. Angle B is given as 65 degrees. Angle C is given as 55 degrees. Therefore, angle A is nothing but this is 120, 180 minus 120 is equals to 60 degrees. Angle BIC is equals to 90 plus angle A by 2, which is 90 plus 30, 120 degrees. Look at the next question. In triangle PQR, the internal bisector of Q and R meets at O. If angle QPR is equals to 70, then what is the value of OQR? QOR. QOR is equals to, we know two internal angular bisectors meet, 90 plus angle P. Angle P, instead of P we are taking QPR by 2. So, it is 90 plus 70 by 2 is 35. 90 plus 35 is 125 degrees. So, major question which involves internal bisectors are based on angles. Either they may ask you two internal bisectors, or else they may ask you two external bisectors, or else they may ask you one internal bisector and one external bisector. Just see the formula so that you can directly put the values in it. All you have to understand the question and where you have to put the value. So, that is all. It makes it your answer in just 10 to 20 seconds. All you have to do in this internal bisector and incenter thing is, you have to remember what happens when two internal angular bisectors meet and what happens when two external angular bisectors meet and one internal and one external angular bisectors meet. So all you have to remember the direct formulas and read the question carefully and put the value wherever it belongs. So it will give you your answer just in 10 to 20 seconds if you are aware of all these formulas. Thank you.